This is B. Naresh, working as an assistant professor in an EC department. And today's topic is problems on CB transistor amplifier analysis. So in this session, we are going to discuss how to solve the parameters related to common base configuration by using the small signal model. So let us see the one problem. For a CB transistor amplifier driven by a voltage source of internal resistance, that is RS is the 200 ohms, and the load impedance is a resistor RL is 1000 ohms. And for this amplifier, the given the H parameters are HIB means that is input impedance for a common base, that is 22 ohms. HRB means a reverse voltage gain, that is 3 into 10 to the power of minus 4. And HFB means forward current gain in a common base configuration, that is minus 0.98. And HOB means output admittance under the common base configuration, that is 0.5 microamperes per volt. For these given specifications, we need to compute current gain, means we need to calculate the current gain, input impedance, and voltage gain, as well as the overall voltage gain. So means we need to consider a source resistance while calculating this overall voltage gain. So similar to that, we need to calculate the overall current gain AAS and output impedance Z0 as well as the power gain AP using the two approaches. One is exact analysis approach as well as the approximate analysis. So in a approximate analysis means, so we take an as that is H4 times of ZL is must be less than of 0.1. Then we go with approximate analysis. So in our exact analysis, we need to consider all the 4 H parameters like input impedance and the reverse voltage gain, forward current gain, as well as the output admittance. So based on these specifications for a given common base transistor amplifier analysis, we need to determine these parameters like current gain, input impedance, voltage gain, overall voltage gain, and overall current gain, output impedance, power gain. So before going to this, first I'm going to specify the given specifications. So if you observe the given problem statement, given the internal resistance, or it is also called as the source resistance, RS is 1200 ohms, and the load resistor, that is RL is 1000 ohms. So hence here I represented with RS is the source resistance is 1200 ohms and load resistance is 1000 ohms. And the 4 H parameters means this is HIB means input impedance, and HRB means reverse voltage gain, and HFB means forward current gain, and HOB means output admittance. So all these 4 parameters are given for a common base configuration. And by utilizing these parameters, we need to determine the specifications like current gain and input impedance, output impedance. So first I am going to use the approximate analysis, means we are not considering any assumptions here. So directly we are specifying all the methods here. For this case, first from the H parameter analysis, and we know that the current gain. So here the current gain is represented as AI. It is represented as minus HFB by 1 plus HOB times of RL. Or you can also write this is minus HFB by 1 plus HOB times of ZL. Either means either load impedance RL or a ZL. So based on this, and we know that the HFB they given that minus 0.98, hence this is minus of minus 0.98 divided by 1 plus, and HOB, so they given that HOB value is 0.5 microamperes, means 0.5 into 10 to the power of minus 6 along with the load impedance RL is 1000 ohms, means this is 1000. So while solving this one, the current gain, it gives that AA is equal to 0.98. The current gain is means, so this is minus of minus, it becomes 0.98 divided by, this is 1 plus 0.5 into 10 to the power of minus 6, and this is 1000 means 10 power 3. So hence this is 10 power minus 3, means this is 0.98 divided by 1 plus, this is 0.0005. So hence that is approximately equal to 0.98, the current gain. So based on the given specifications, the current gain is represented as 0.98. Then we need to calculate the input impedance. So that impedance is represented as either Ri, or it is also represented with Zi. Again, from the small signal analysis, from the H parameter representation, the input impedance is represented as HIB plus HRB times of AI into RL. So here, HIB is a known parameter and HRB is also known parameter. RL is a known parameter. AA just now we got this value. So what is how much value AA? We observed that 0.98. So hence, I'm going to substitute all these parameters here. So hence, HIB value is 22 ohms. So this is, so HIB is a 22 plus HRB is 3 into 10 to the power of minus 4, and current gain, that is current gain is we observed that 0.98, and a load resistance RL value is 1000 ohms. Now I can simplify this one. Then it gives that the RA is 22.3 ohms. The input impedance of the common base transistor amplifier analysis, based on these given specifications, that value is 22.3 ohms. Now similarly, we need to observe the voltage gain. The voltage gain is represented as from the H parameter analysis. Now we are going to calculate this voltage gain. According to the H parameter analysis or a small signal model analysis, the voltage gain is represented as AA times of RL by RI. So just now we got this RA value. What is RA value? RA value is 22.3 ohms. Hence, I consider this RI, or it is also called as the ZI, that is 22.3 ohms. Hence, now here I am going to substitute these values. So where we know that the current gain of CB amplifier is 0.98 into RL value is 1000 divided by RA value, we got that 22.3 ohms. So now I can simplify this one. Then it gives that the voltage gain of common base amplifier is 43.946. And now similarly, we need to calculate the voltage gain, means overall voltage gain. Means in this, the overall voltage gain, we need to consider the source resistance. So if you want to take the small signal model, so we have, this is input impedance and reverse voltage gain, and this is forward current gain, and this is output admittance. This is HIE, HR and HF, and this is the HO parameter. So at the input side, I'm going to place a source resistance, that is RS. So hence, we need to consider, if you want to calculate the overall voltage gain or overall current gain, we need to include this source resistance. Hence, from that, the voltage gain along with the source resistance is defined as, it is a ratio of voltage gain with the RA to the that input resistance along with the source resistance. And where, so we observe this voltage gain AB parameter as well as input impedance parameter, then in the given problem statement they are specifying the source resistance value, that is Rs. So for this case, if you observe, the AV value is 43.946, hence the AV value is 43.946. Now in this relation, now you can substitute the values. So AV is 43.946 into RA value is 22.3 ohms divided by RA value is again 22.3 plus RS value is 1200 ohms. Now you can simplify this analysis, then it gives the AVS. When you are considering the source resistance, now the source overall voltage gain is reduced from the 43.946 to 0.802. So this is a overall voltage gain in a common base configuration. So similarly, we need to calculate overall current gain. So then overall current gain, or it is also called as current gain including source resistance, and it is represented as AIS. So here we are going to calculate the overall current gain in terms of the source resistance, hence I am going to utilize the current gain, that is AA times of RS by RA plus RS. So we know that AA value is 0.98 and RS is 1200 ohms by RA is 22.3 plus RS is 1200 ohms. We can solve this ratio, then it gives that the overall current gain means including the source resistance, that is equal to 0.962. So without the source resistance, the current gain is approximately equal to 0.98. And while you are considering the source resistance, that 0.98 is reduced to 0.962, but there is no maximum deviation, but a small deviation is occurred while inserting the source resistance. But if you observe the overall voltage gain compared with the normal voltage gain, a maximum deviation is observed with considering the source resistance for a common base transistor amplifier. Now we are going to calculate. So to determine the output impedance, so the output impedance is represented as a Z0. So Z0 from the H parameter analysis, the Z0 is represented as the reciprocal of the admittance, hence 1 by Y0. So hence first we need to determine the admittance based on the small signal analysis. So for this case, the admittance is represented as HOB minus HFB into HRB by HIB plus RS. So now you can substitute the given specifications here. So HOB is represented as 0.5 microamperes, means micro means 10 to the power of minus 6, that is ampere per volts, minus HFB they given that minus 0.98 into the reverse voltage gain HRB is 3 into 10 to the power of minus 4 divided by HIB is a 22 ohms plus RS is 1200 ohms. Then you can simplify this one. Then it gives that Y0 is equal to 0.7405 microampere per volts. So from this, now we need to calculate the Z0 parameter, or it is also called as R0, the total output impedance at the output side. Hence Z0 or R0, it is nothing but a reciprocal of admittance. So hence 1 by this is 0.7405 into 10 to the power of minus 6. If you solve this one, then it gives the R0 or a Z0, that is equal to 1.35 mega ohms. So this is the Z0 value. Z0 value is 1.35 mega ohms. Now again in that problem they are asking that the power gain. So generally we know that power is a product of voltage and current. So we know that this relation P is equal to V into I. So hence we are going to determine the power, the gain in terms of power. So means power in terms of gain. So hence AP is equal to, so the voltage gain is a product with current gain. So simply that is the reason I represented as the power gain is equal to the product of AV and AI. So where AV is 43.946 and current gain is 0.98. So hence this is 0.98. So AA value is 0.98 and the voltage gain is 43.946. Hence it gives that the power gain is 43.06. So hence, so if you observe the statement, and based on the given statement, they are asking the current gain. We also calculated input impedance, voltage gain, overall voltage gain, and the current gain, overall current gain, output impedance, as well as the power gain. So by using the exact analysis as well as the approximate analysis. So up to this point, all these parameters are determined by using the exact analysis. Then we go for approximate analysis. So generally, when we go for approximate analysis, means based on the configuration, H4 times of ZL is must be less than of 0.1. Then we go for or ZL is nothing but a load impedance, means H4 times of RL is must be less than of 0.1. So then we can go for approximate analysis. Hence, for the same specifications, now we are going to observe what is approximate analysis methods. So in that approximate analysis, now we are going to calculate the parameters that is related to common base transistor amplifier. So hence, now I'm going to choose this approximate analysis. So in this approximate analysis and from the H parameter model or a small signal model analysis, the AA is represented as only the minus HFB. The current gain is directly proportional to the small signal forward current gain, that is minus HFB. So here they represented that HFB value is minus 0.8, hence AA is equal to minus of, this is minus 0.98, hence the current gain is approximately equal to 0.98. So in the exact analysis also, we got that the current gain is 0.98. Then now we are going to calculate the input impedance. So that input impedance is represented as either Ri or Zi, and this Ri or Zi that is equal to HIB in approximate analysis. So hence from this representation, either Zi or Ri that is equal to HIB value is 22 ohms. But in exact analysis, we got that there is ZRI value is 22.3 ohms. But there is no deviation. A small minor deviation is observed with approximate analysis or a exact analysis method. So hence from this, the input impedance ZI and RI is represented as 22 ohms. Similarly, now we need to calculate the voltage gain. So the voltage gain using approximate analysis. Using approximate analysis, AV is represented as HFE times of RL by HIE. So why we represented actually HFE by HIE? So in approximate analysis, now we observe that AA is equal to HFE, and RI or ZI we also observe that HIE. So that is the reason. So simply I represented as HFE times of RL by HIE. But in exact analysis, we represented as that is AA times of RL by, then it is represented as RI. But in approximate analysis, this AA is equal to HFE, hence is replaced with HFE, and RI is replaced with HIE. So that is the reason. So now we are going to substitute this HFE and RLHIE values to determine this voltage gain. So AV is equal to HFE value is, but first we need to calculate this HFE parameter. So actually this is related to common base configuration. So in this they given that HFB, but we need to convert this term in terms of given specifications are related to common base configuration, but here the HFE means that is related to common emitter configurations. So hence, so we need to convert this HFE in terms of common base. And we know that in a common emitter configuration, the DC current gain is represented as beta. So the DC current gain is measured in a common emitter amplifier, that is represented with the beta. Similarly, if it is a common base amplifier, the DC current gain is represented as alpha. So hence, if you want to write this beta in terms of alpha, beta is equal to alpha by 1. So 1 minus alpha. So hence, here I represented as HFE is represented as minus HFB by 1 plus HFB, alpha by 1 plus alpha. So hence this is minus HFB by 1 plus HFB. So hence HFB value is minus of 0.98 divided by 1 plus, this is 0.98. So if you solve this one, so hence this is 0.98 divided by 1.98, hence this HFE is becomes 49. So now I'm going to substitute this HFE value here, and again before that we need to calculate HIE, but in our given specifications there is no HIE parameters, but we have that HIB parameters. Hence, first we need to convert this HIE in terms of HIB values. So that is the reason I'm going to write this HIB. So we know that HIB is equal to HIE by 1 plus HFE. So from this we need to calculate HIE. So how to calculate this HIE? HIE is equal to, so this is HIB is multiplied with 1 plus HFE here, hence. So then you can substitute that value. So hence, so from this relation, we observe this HIE is equal to HIB times of 1 plus HFE. So we know this HIB is at 22 ohms and 1 plus HFE, we got this, just now we observed this HFE value, that is 49, hence this is 22 into 50, then this HIE value gives that, so 1100 ohms. So now, so based on this parameters, now we got this HIE values as well as HFE values. HFE we got that 49 and HIE we got that 1100 ohms. Now by using these two parameters, now I'm going to calculate the input impedance parameter, voltage gain parameter. So hence the AV is represented as HFE times of RL by HIE. So what is HFE value we observed? HFE value is a 49 and the load resistance they given that 1000 ohms, and HIE value is we observed that 1100 ohms. So hence after simplification, then it gives the voltage gain is equal to 44.54. So if you observe in a approximate, in an exact analysis also, the voltage gain is represented as in exact analysis method, the voltage gain is 43.946. So 43.9 means approximately this voltage gain is equal to 44. So in a exact approximate analysis also, we observed that, so we got this 44.54, means the small minor deviation, that is 0.54 deviation is observed with exact analysis and approximate analysis. So similarly, similar to with this, now we need to calculate the overall voltage gain in terms of by using this approximate analysis. So here the overall voltage gain is represented as AVS. overall voltage gain, or the voltage gain with respect to the source resistance, or while considering the source resistance. In an approximate analysis, that is represented as AVS is equal to AV times of RI by RI plus RS. So with the approximate analysis, we observe that the voltage gain is 44.54, hence this is 44.54, and RI is, we observe that is a RI is in nothing but that is equal to HIB in a approximate analysis, hence RI value is at 22 by, then you can substitute this RI value is at 22 plus the source resistance value is 1200 ohms. Now you can simplify this one, then it gives the voltage gain, overall voltage gain with the source resistance, that is equal to 0.802. This is overall voltage gain of the common base amplifier under approximate analysis. Similar to that, we need to calculate the overall current gain. So that is represented as the overall current gain. The overall current gain, it is represented as AIS, that is AIS is equal to AA into RS by RA plus RS. So we got that AA is, so this is an approximate value, approximate measure under approximate analysis. We got this current gain is 0.98, hence this is 0.98 into the source resistance is 1200 ohms divided by the input resistance under the approximate analysis 22 ohms plus, and RS is 1200 ohms. Then you can solve this ratio, it gives the current gain and overall current gain along with the source resistance, that is equal to 0.962. Now similar to that, we need to calculate the output impedance under this approximate analysis. So if you want to calculate this output impedance under the small signal analysis, we know that the Z0 is the reciprocal of output admittance, that is nothing but a 1 by Y0. So hence, and again, so here we taken as in approximate analysis, we neglected that output admittance. Why? Because of we consider that H4 times of ZL is must be less than of 0.1. Hence, we neglected this. Means that is we consider as equal to 0. So in approximate analysis, we taken as H4 times of ZL or H4 times of RL is must be less than of 0.1. Then we neglected the output admittance and we neglected the reverse voltage gain. And in general, we know that this output impedance is the reciprocal of output admittance. And here we neglected this admittance, means we consider as admittance is a 0. So that is equal to very smaller value. So means 1 by 0 means Z0 is R0, that is equal to infinite value. So hence, in a approximate analysis, the R0 is means it indicates that we need to offer very maximum output impedance for this common base transistor amplifier. So similar to that, now we need to calculate the overall power gain in terms of approximate analysis. So again, we know that this power gain is represented as is a product of voltage gain and current gain. So we got this current gain is 0.98 and the overall voltage gain is 44.54. Hence, so now we need to substitute the voltage gain value as well as the current gain value. So we know that the voltage gain is 44.54 into the current gain value is 0.98. So now can solve this one. It gives that the power gain is 43.65. So up to this point, we observed that the common base transistor amplifier analysis parameters based on the given specifications using the exact analysis model as well as the approximate model here. Then we are going to discuss one more problem. Calculate the values of input resistance, output resistance, current gain and voltage gain for the common base amplifier circuit shown in below figure. The transistor parameters are HIB is 24 ohms, HFB is 0.98 ohms, HOB is 0.49 microamps per volts, and HRB is 2.9 into 10 to the power of minus 4. And this is the given figure for this given common base amplifier circuit. So in that they are specifying that some parameters like source resistance, RS is the 600 ohms, and emitter resistance. So this is the common base. Base is the common for input side as well as the output side. So in this common base configuration, we know that emitter is acts as a input terminal and the collector is acts as the output terminal. Hence, for this emitter, we connected the source resistance as well as the emitter resistance. And here the source resistance value is 600 ohms and emitter resistance is 6 kilo ohms. And coming to the output side, the collector terminal is acts as the output, hence the biasing of collector resistance is 12 kilo ohms. And across the output, the load resistance is 14 kilo ohms. So by using this common base amplifier configuration and based on the given specifications of this small signal model parameters, then we need to determine the input resistance, means Zi or Ri, as well as output resistance Z0 or R0, and current gain and the voltage gain. So we need to calculate these four parameters related to give it this common base amplifier circuit. So before that, first we need to identify the given specifications. So based on the given figure, and we know that the source resistance is 600 ohms and Re is 6 kilo ohms. So hence Rs is 600 ohms. They provided Re is means emitter resistance is 6 kilo ohms. And they also provided the collector resistance is 12 kilo ohms and the load resistance is 14 kilo ohms. And apart from that, they are also providing this H parameter model parameters or small signal model parameters like HIB means input impedance, or it is also called input resistance, and this is forward current gain and output admittance. HOB means output admittance, and reverse voltage gain. HRB means reverse voltage gain. So based on these given specifications, now we need to calculate the input resistance, output resistance, voltage gain as well as the current gain by using the exact analysis method. So for this case, I am going to consider the H parameter analysis or a small signal model analysis. So we know that, so if you observe this one, the circuit, so the output side, we have the two resistances, collector resistance as well as the load resistance. Hence, I'm going to use the representation. The current gain is represented as minus HFB by 1 plus HOB times of RL dash. And where RL dash means, if you observe this one, so these two resistance, when we are passing the AC signal, that this K2 is acts as a short circuit. So whenever it is acts as a short circuit, this collector resistance and the load resistance, these two are a parallel combination. So hence, RC is a parallel with RL, that equivalent resistance I considered as a RL dash. That is the reason. In this case, I considered as where RL dash is the parallel combination with RC and RL. Hence, what is the RC value they given? RC value is 12 kilo ohms, means 12 into 10 to the power of 3. RL value is 14 kilo ohms, means 14 into 10 to the power of 3. Parallel combination means, so RC, RL by RC plus RL. So RC value is again 12 into 10 power 3 plus 14 into 10 power 3. Then you can solve this one. It gives the equivalent parallel resistance is 6.46 kilo ohms. Now we need to substitute these values into to observe the current gain. Hence, so what is the current gain? A is minus HFB, so means 0.98. Then you can consider this is minus again by 1 plus HOB is 0.49 into 10 to the power of minus 6, and RL value is 6.46 into 10 power 3 kilo ohms. Then you can simplify this one. It gives the current gain is 0.977. And similarly, we need to calculate the input impedance, that is Ri or Zi. So we know that this Ra from the H parameter analysis, Ra or Zi is represented as HIB plus HRB times of AI into RL dash. So in the previous case, we observed this current gain as well as equivalent parallel resistance. How much whatever we observed, RL dash is 6.46 kilo ohms and the current gain we observed at 0.977. So hence, now I'm going to substitute these values. So HIB value is 24 ohms, 24 plus HRB is 2.9 into 10 to the power of minus 4 and the current gain is 0.977. RL dash is 6.46 into kilo ohms means 10 to the power of 3. So if you solve this one, then it gives that the RA value is 25.83 ohms. The input impedance of a common base transistor amplifier analysis. Based on the given statement, we observe that the total input impedance or a input resistance that is 25.83 ohms. So then now we need to calculate the voltage gain that is represented as AV. Again, the voltage gain from the small signal model analysis or H parameter model analysis, it is represented as AV is equal to AI times of RL dash by RI. So where AI is 0.977 and RL dash is 6.46 into 10 power 3 divided by RA value is 25.83 ohms. So where the current gain is 0.977, RL dash is 6.46 into 10 power 3, that is kilo, and RA value is 25.83. Then you can solve this ratio. It gives that the voltage gain is 244.34. So this is for a voltage gain for a common base transistor amplifier analysis. Similar to that, we need to calculate the output impedance. So means the output impedance means we need to calculate R0 or a Z0. So from this small signal model representation, either R0 or a Z0 is represented as the reciprocal of output impedance, that is nothing but 1 by Y0. So hence first we need to calculate the output admittance, that is represented as Y0 is equal to H4B minus HFB into HRB by HIB plus R dash S. Again, we need to calculate what is this R dash S. Actually, we need to consider in a previous problem we observed that only the RA, but here we need to consider R dash S. Means if you observe the given figure, in that figure they given that the input side emitter is biased with RE resistance and it is also connected with a source resistance, that is RS. So that is the reason. And when the input signal is passing through the common base amplifier circuit, and the input side we have the two resistances, one is across the emitter side, one is across the source resistance, external source resistance. Hence, we need to take that equivalent resistance. So hence, where that R dash S is represented as the parallel combination of source resistance as well as the emitter resistance. So why? Because if you observe the circuit for the given specifications, so here if you observe this one, so and the signal is passing means C1 is a short circuit. So what happens? This RS is a parallel combination with input side, emitter side. We have the two resistance, that RI is a combination with RS and RE. So hence this RS and RE is a parallel combination. That is the reason here I use the parallel combination of these two resistances for calculating the R dash S. So means this R dash S is represented as RS into RE by RS plus RE. So what is the RS value? 600 ohms. 600 into RE value is 6 kilo ohms. 6 into 10 power 3 by 600 plus 6 into 10 power 3. If you solve this ratio, R dash S is equal to R dash S, that is equal to 545.4. And we know that if the two resistances are unequal and the parallel combination is always used at equal to smaller resistance value. So here the smaller resistance is the 600 ohm, that is nearer to the smaller resistance value. Hence, R dash S is that is equal to 545.45 ohms. Now we need to substitute here to determine this Y naught. Y naught is equal to HOB. HOB means 0.49 into 10 to the power of minus 6 minus of HFB. What is HFB value? 0.98 into HRB means 2.9 into 10 to the power of minus 4 divided by HIB. The HIB value is 24 plus R dash S is 545.45 ohms. Now if you solve this ratio, it gives that Y naught is equal to 0.989 microamperes per volts. So from this, now we need to calculate the output impedance. Hence, I am going to calculate. So we know that either Z0 or R0 is nothing but the reciprocal of output admittance. Hence, that is 1 by Y naught. So from this representation, this R0 or the Z0, 1 by Y naught. So what is the Y naught value? We observe the Y naught value is 0.989 microamps per volts. So hence 0.989 microamperes per volts means 1 by 0.989 into 10 to the power of minus 6. Micro means 10 to the power of minus 6. So if you solve this one, the R naught is equal to 1.011 mega ohms. So up to this point, today we observed that some of the problems are related to the common base transistor amplifier analysis by using the small signal model. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.